Alright, so a couple things. First of all, got a retainer, so it's going to make it a little bit more difficult to talk, and I'm going to sound like an idiot while I do this. Yeah, deal with it like I am. Second of all, it's time to learn a little bit more about the rules which I showed in the previous video, and show why they work, how they work, and essentially prove them. I know that MathsChan already did this with the product rule. He stole my idea. I'm very upset with him, but it's okay. I forgive him. If you're watching this video, MathsChan, it's okay. I forgive you. You're good? Yeah, quick. Alright, so before I go forward with it, just to quickly summarize, one thing you really need to know is function notation. So essentially just f of x is a function of x. So like if I put in 6 to this function, I just substitute 6 for x. So like 6 cubed minus 5. If I did x plus h, it'd be x plus h cubed minus 5, and so on. Hello, you okay?
Yeah.
Just enjoying watching me talk to a camera?
Is that
What? Yeah, it's fine.
okay?
That's why I'm still filming, otherwise I'd stop filming.
Yeah, right.
Okay, so you can also use like g, y, h, doesn't matter what you use for f. You can even use sine if you want. That's what sine of x means. It's just a function called sinus or sine. If I said y of x and I said y prime, that apostrophe y prime of x, that just means the first derivative. Double prime, second derivative. If I do a little bracket here with a 3 in it, it's a third derivative. And I'm pretty sure you can guess what the 4 is meant to mean at that point. And that's all you really need for the rest of the video, so hopefully you understand that, and let's get straight into it. Alright, so the first thing that we went over last time was I hate with this stupid retainer. The last thing we went over was the sum rule, where essentially if you have a function like f of x plus g of x, two random things that could be anything of x, if you differentiate them, you will get the differential of f plus the differential of g. And we're going to show that now. So if you remember first principle, you'll know y prime, the derivative of y, will equal this whole expression. And we'll just plug this straight in. So as h goes to 0, just plug in x plus h into that expression. Right, at that point we can now separate what we've got into f and g, and you'll see why in a second. So if I take the limit as h approaches 0 of x, right. Why are you looking at me like that?
What do you mean?
Why are you looking at me?
Huh?
Why are you looking at me like that?
Sorry.
Stop looking at me. What we're going to do now is we're going to separate our fraction into like f and g. And you'll see why, as soon as I put it together, why it makes sense. If I do, double I, okay. Limit h approaches 0, take the f of x, subtract f of x, put it over h, add a limit, we're going to split the limit up into two fractions. G of x plus h, and then minus g, so that minus gets expanded out. Put it over h. You'll notice this is the same form as the first principle, and so is this. So what are they? Well, this is just going to be f prime of x, and this will be g prime of x. So our y prime is going to be all of this. And that's how I know that I can just split up the derivative into separate parts, which is way easier to know that than it is to know that. Moving on. Okay, just did the sum rule, now we're doing the product rule, which is way easier to say when you've got a Lisp. So, y of x equals fx times g of x this time. They're like a product. You put them together and now it's a lot harder to solve for. So once again, we'll plug in x plus h into this. So f of x plus h times g of x plus h, same as we did last time, minus y of x, which is f of x, g of x over h, like that. Now, we are not those same mathematicians which had to solve this like centuries ago on their own. We actually know what the answer is. We know, well, I can't write. we know that the answer for this is going to be y prime is derivative of f times g plus f times the derivative of g, like that. And we can break that down a little bit more. We know that so we can break this down. We know that f prime is going to be f of x plus h minus f of x over h with that limit going on. And we know that the same is going to be for g. So we somehow need to get it. So we've got this times by g, and we've got that derivative times by f. Well, I know that I've got a minus f of x here and a minus f of x here. And this one's times by g, which is exactly what I need. So we need somehow to get an f of x plus h times by g. So what if I just add that into the fraction? But the thing is, whatever I add, I have to take away as well. So from that, we can do y prime is the limit, and we can separate it now like we did last time. We've got f of x plus h minus f of x, both times by g. So we'll write that in here, f, that's all times by g of x, mind you, and over h. And then once again, we'll split it into another limit. We've used this one and this one now. All we've got is this and this left. And look at that, they've both got f of x plus h in them. So g of x plus h minus g of x. And then over h. Cool. Now, this, let me get this a pen. This we know is going to be f prime, and it's going to be times by g. And then this we know is g prime going to be times by f. And so we can bring this all down and say that y prime equals f prime times g plus f times g prime. Or in other words, y equals the derivative of the first function times the second plus the first function times the derivative of the second. Bit wordy, but hopefully you can see the general idea. And once again, we don't need to know any of this, we just need to focus on this rule and use it going forward. So for the final one, the chain rule, there are, three different ways I can explain this to you. One is a kind of dodgy perspective, one is a really good perspective, and then the other is a really long proof that I don't want to do, but I'll do anyway, because why not? First perspective is not really correct, but I thought I'd show you anyway, is if you've got some kind of function like y of u of x, you can be like x squared, x cubed, it could be sine x, whatever. And y could be anything like sine e to the whatever, I don't know, you don't know what it is. You just know it's a function. Essentially a function in a function. What I can do is I can take the derivative of the outer one, y, with respect to u, which is just u, and then I can take u of x separately and find the derivative of u with respect to x and multiply them together. So dy du multiplied by du dx. The reason this works, you can imagine crossing out and cancelling out these du's, which just gives you dy dx like that. Bit dodgy because it's not the best way to imagine it, but it definitely helps to remember it. Here's a much better perspective that I took from a channel called MAKiT. I really highly recommend you go check him out. He does amazing work on his channel and he can explain this stuff way better than I could. The idea is, imagine you've got three cogs, x, u and y, same as what we have over here. I'm asking, if I rotate x just an amount, let's say a tiny little amount, how much does u change? And then based on that, how much does y change? And I want to find out the direct link between x and y, the dy dx. Literally, I'm asking, if I change x a little bit, how much does y change? To do that, I have to find out how much does u change after x changes. So that will be du dx, like that. Then I find out how much how much y changes with respect to u, that key terminology with respect to. So I find dy, change in y, over the little change in u. And then I put them together, I multiply them. Dy dx equals dy du multiplied by du dx, which is exactly what we have over here. In function notation, like up here, if you're wondering, that means that y prime equals f prime of g multiplied by g prime of x, like that. Now for the proof, which I'm not excited to do, but I'm doing anyway because I have nothing else to do on a Friday afternoon. So we'll go back to first principle again. Y prime is going to be the limit as our h approaches 0 of the fraction f of g of x plus h. Remember, just substitute x plus h into that, and then minus f of g of x, like so. Put it over h. Good. Now what? Well, I know my answer. Once again, we can use that to our advantage. It's going to look something like this, times by g of x. Sorry, g prime of x. So we need to get our derivative of g outside somewhere. How can we do that? Well, we know, different colours, sorry. We know that this is going to be the whole g of x plus h minus g of x over h. We know it's going to be all of that. Have we got any of that there? We do, but they're kind of stuck inside all these functions. But we have the h. So all we would need to do is just take this on its own, multiply it to that fraction, and then we would have this over that. But the thing is, because we don't want to change what we've got here, whatever we do to the top, we must multiply by that amount on the bottom so that it stays the same. So as you can see now, we've got our g of x plus h minus g all over h, which is, when applied with that limit, going to give us g prime of x. All right, cool. So now we've got g prime of x. But what about this whole thing here? That's going to be tricky to show. But we can kind of figure it out. We just need to get some graphs up. So I'm going to get that up and we can see if we can break this whole random mess there into something a little bit more readable and understandable so we know what we're saying. To start now. Okay.
Don't forget to stretch.
What? Don't forget to. My tongue just coming out a bit.
You aged 20 years.
Shut the We have to try and make sense of what we've got up here, because right now that just looks like nonsense. But if we make a graph of f of x, our main function, and then we'll just let this line be g of x. If I go a certain distance along x amount, this will be g of x. Make sense, right? We can go up to the function, and our height will be f of that point, g of x. Cool. And then what if we go, I don't know, h steps along to get g of x plus h. Bring that up, and you get f of g of x plus h. Bit weird, but stay with me for now. If I want to take this here, I get my delta x, right? And that's going to be g of x plus h minus g of x. Cool. Then I can take my delta y, right? And that will be f of all that crap minus f of g of all that crap, right? And then, if I really wanted to, I could write delta y over delta x, which will be f of g of x plus h minus f of g of x over g of x plus h minus g of x. And then, cool, so what do we do then? Well, I don't know about you, but this looks pretty similar to this. This. That's because they are the same thing, if you can already tell, like Alex over there sitting in the corner who's absolutely brain dead. So to find a derivative we're simply just going to take it as a limit. But remember, we don't take the limit as h approaches 0, we find the limit as our delta x, which is this whole thing. So actually, you change this to be delta x, which is this whole thing here, and what we'll get is the derivative of our function here, the main one, which I pointed out earlier, is f prime, and then of g of x. And that's the penultimate step in proving the chain rule. Switching back to the main footage, which I recorded earlier. So then, going back to this part here, if we say that our little change in x is going to 0, and we've got our point A at g of x plus h, and our point B at g of x, once again we're saying apply a function f to them, make them come together. This part right here, let me circle it. This is just going to be our delta y. So we've literally got a delta y over a delta x as it goes to 0. Our derivative. And what is it the derivative of? Well, it's of f of g of x. So it'll be f prime of g of x, and then we multiply it by, one moment, we multiply it by g prime of x, and done.